It began with Earth's most coveted stone. For millennia, diamonds have been symbols of permanence, fragments of the cosmos, compressed in the heart of the Earth into brilliance that resists time. Kings and conquerors coveted them. Lovers pledged eternity with them. In their cold fire, humanity saw beauty, resilience, and immortality. Yet what we call rare on Earth may be common across the stars. There are whispers of a world sculpted almost entirely from diamond. 41 light-years away, orbiting a star in the constellation of Cancer, exists a planet unlike any in our system. Astronomers call it 55 Cancri e. Twice the size of Earth, 8 times as massive, and so close to its star that it completes an orbit in less than a single Earth day. A world locked in eternal fire. Its surface may be oceans of molten rock, its skies shimmering with vaporized minerals. And beneath that blazing crust, scientists believe lies something extraordinary, a mantle not of iron, but of crystallized carbon, a world forged of diamond. On Earth, we treasure a carat. On 55 Cancri A, there may be quadrillions of tons. Mountains, continents, even whole worlds of diamond, hidden forever beyond reach. In this truth lies a paradox. The universe creates beauty not to be possessed, but to remind us how small our treasures are in the face of cosmic abundance. The story of 55 Cancri A begins not with diamonds, but with shadows. In the early 1990s, astronomers sharpened their tools toward a single goal: to detect planets orbiting stars beyond the sun. For centuries, such worlds were speculation. But with the rise of radial velocity measurements, the subtle tug of a planet's gravity on its parent star, whispers of unseen companions began to appear in the data. In 1996, a breakthrough, the discovery of a giant planet orbiting 55 Cancri A, a sun-like star just 41 light-years away. Over the years, more planets were uncovered in this system, forming a miniature solar architecture. But it was not until 2004 that the smallest of them revealed itself. A world skimming so close to its star that its orbit lasted only 18 hours. This was 55 Cancri A, first glimpsed not directly, but as a trembling in the light of its star, a periodic dimming as the planet transited across its fiery host. What they found was puzzling. At first, astronomers believed the planet to be a gas dwarf, a shrunken Neptune wrapped in thick clouds. But measurements from space telescopes, NASA's Spitzer, Europe's Cheops, and later Hubble, painted a stranger picture. The planet was rocky, dense, and searing hot. Its day side blazed above 2,000 degrees C, hot enough to vaporize metals. Its orbit was tidally locked, leaving one hemisphere in endless day and the other in endless night. And then came the chemical clues. Spectral studies hinted at an unusual composition: carbon-rich, lacking the oxygen dominance that defines Earth. Theorists began to run models. If this world formed in a carbon-rich nebula, its core could be layered not in iron and silicate, but in carbon compounds. Under crushing pressures, that carbon would crystallize. The conclusion was staggering. 55 Cancri E might not just be a rocky planet. It could be a diamond world. The suggestion was both exhilarating and unsettling. Earth's diamonds are rare, born in narrow conditions deep beneath its crust. But here was a world where diamond might not be a gem, but a geology, a fundamental building block of its surface and mantle. A planet where what humanity deems priceless could be as common as dust. The shock ran deeper than mere wealth. If such carbon-dominated worlds exist, then our assumptions about planetary formation were incomplete. For decades, scientists assumed that rocky planets would resemble Earth: silicate crusts, iron cores, atmospheres of oxygen, nitrogen, and carbon dioxide. But 55 Cancri E suggested an entirely different blueprint. Its orbit also defied expectations. So close to its star, the planet should have been stripped of atmosphere and burned to ash. Yet its density hinted at survival. An unyielding structure forged from carbon, able to withstand heat and pressure unimaginable on Earth. It seemed to violate the rules of habitability, stability, and even planetary chemistry. To the public, the idea of a diamond planet stirred visions of unimaginable riches. To scientists, it was a mirror held up to human arrogance. If diamonds are common in the cosmos, then rarity is only a parochial illusion, confined to Earth. The universe does not shape itself to human value. It sculpts worlds according to physics, chemistry, and chance. The deeper astronomers looked, the stranger 55 Cancri E became. Observations with NASA's Spitzer Space Telescope revealed fluctuations in its heat signature. Some nights the planet appeared even hotter, suggesting volcanic activity or molten lakes that shifted across its surface. Other data suggested a thin, dynamic atmosphere, not breathable air, but a shroud of vaporized minerals and carbon. The European Space Agency's CHEOPS mission added precision. Its transit light curves showed tiny variations, implying that the planet's orbit may even be slightly elliptical, causing wild swings in surface temperature. Models suggested rivers of lava, or perhaps a mantle shimmering with crystallized carbon beneath a molten crust. But the greatest mystery came from its spectra. Some readings suggested silicates, others hinted at hydrogen cyanide, a poison on Earth, but evidence of carbon-dominated chemistry on a planetary scale. Was the atmosphere evaporating? Was it replenished by volcanic vents? Or was the planet shedding its very skin into space, leaving only its diamond heart behind? Each measurement contradicted the last. 55. Cancri A became a puzzle that refused a single solution. Some scientists argued that it might not be a diamond planet at all, but rather a volcanic hellscape coated in silicates. Others defended the carbon-rich model, pointing to its mass and radius as evidence that Earth-like assumptions could not explain it. The deeper the data went, the more the planet mocked certainty. Then came the escalation. If 55 Cancri A truly held vast quantities of carbon, crystallized under pressures beyond imagination, it would not be alone. Models suggested that diamond planets could be common in carbon-rich systems across the galaxy. Entire worlds glittering unseen, hidden beneath molten skies. But 55 Cancri A raised darker mysteries. Its temperature maps revealed something deeply unsettling. The hottest point on the planet did not align with the star's glare. Instead, heat seemed displaced, as if winds of vaporized rock swept energy across the surface, or as if volcanic eruptions released infernos from within. The planet did not behave like a dead, silent stone. It breathed fire. And then there was its orbit. Over time, astronomers noticed signs of orbital drift, subtle but measurable. Was 55 Cancri E spiraling inward toward its star, destined to be consumed in a tidal inferno? Or was gravitational resonance with its planetary siblings pushing and pulling it in unseen rhythms? If so, the system itself was unstable, a cosmic dance on the edge of destruction. The deeper the investigation, the more 55 Cancri A appeared less a static diamond and more a furnace, alive, unstable, dangerous. A world where beauty and terror were indistinguishable. Oh, explain 55 Cancri A, theories multiplied. The diamond hypothesis remained compelling. A planet born from carbon-rich gas, crystallized under crushing mass. If true, it proved that worlds could form along pathways utterly unlike Earth. Others proposed volcanic hyperactivity, a world constantly resurfacing itself in lava oceans, producing fleeting atmospheres of mineral vapor that shift with every eruption. Some speculated about a supercritical ocean of carbon dioxide, dense and hot, trapping heat in ways unlike any known planet. And then came the more exotic ideas. Could 55 Cancri E be the remnant core of a gas giant, its atmosphere stripped away by stellar winds, leaving behind a crystallized carbon husk? Or might its chemical anomalies point to processes we do not yet understand? Carbon phases beyond diamond, unknown states of matter under alien pressures. In its contradictions, 55 Cancri A whispered of physics yet unwritten, a reminder that every discovery is a door to deeper ignorance. Today, 55 Cancri A is under the gaze of our most advanced instruments. NASA's James Webb Space Telescope has already turned its golden mirrors toward the planet, hunting for signs of its atmosphere and surface chemistry. Webb's infrared eyes can dissect the faintest glimmers of starlight passing through the planet's vapor, mapping its composition atom by atom. Future missions, like the European Athena X-ray Observatory and the Ariel mission, will push further, testing whether diamond planets are rare anomalies or common children of carbon-rich stars. Computer simulations on Earth now recreate their formation, compressing billions of years into hours, testing whether cores of crystallized carbon truly emerge under such conditions. Even gravitational wave detectors, in decades to come, may sense the subtle quakes of planets like 55 Cancri A as they strain under tidal forces. Science is building a toolkit not just to see such worlds, but to hear them. In the end, the story of 55 Cancri A is not about wealth, nor even about diamonds. It is about perspective. On Earth, humanity treasures a stone so small it can fit in a hand. Yet out there, entire worlds of diamond burn unseen, untouchable, their beauty wasted on the silence of space. Perhaps that is the universe's lesson. Value is not written in matter, but in meaning. Diamonds are not rare to the cosmos. They are rare only to us. 55. Cancri E is a mirror, reflecting both the brilliance of nature's creativity and the limits of human desire. It is a furnace of fire, a monument of crystal, and a reminder that the universe owes us nothing. It shapes beauty without witness, treasures without owners, and mysteries without end. And so, the diamond planet shines unseen in the constellation of Cancer, its infernal light hidden from our eyes. Not to be mined, not to be possessed, but to remind us, in its silence, of what the universe truly is. A story of endless creation, whose greatest treasures are not what we can hold, but what we can only imagine.